It's Roger, Mudfossil University, talking about how the organic things in the world petrified in the last great flood, and how opals are even body parts such as this opalized heart. Now we're going to go over how this happens and why these colors appear and why they didn't rot and how they are in such unbelievable abundance, and what is the whole story of our history, and let's discuss the whole thing. Alright, so let's try to clear up some issues. How can I say that all of these rocks are mud fossils? How can I make that statement? Well, first of all, there's the chemistry, there's the anatomy, and I fully understand it, and I've recreated the process. And I can tell you exactly what we're talking about here, how tissues transform into minerals and stone and the things that we see as mud fossils. Now, there's different types of body parts in your body. There's different chemistry, and we go through the keratins and kerogens and all this business, and the collagen and all the things that your body has to work with, and there's hundreds of them, literally. And when you put them together in these molecular formulas, there's literally millions of combinations for it to work with to create things that are resistant to acids and to salts and to abrasiveness, and other ones that are literally inert, like your blood vessels and so forth. They just really almost don't deteriorate. Your tendons are just strong, strappy little bands that last literally forever in your body. When they break, they just don't repair themselves well at all. Now, let's talk about the whole story here. How did they get preserved? Oh, it's impossible. It's about they'd rot, they do this. Well, the whole thing is salt water is the key. There was a great flood. It was written about in every culture, so don't say, oh, you're creationist, which is exactly what happened in the academic arena. They just dismissed everything just because of the fact of God and creationism. So just forget that. Just drop that right off the table. Let's look at what exists. Now, Harvard and all of them now, Max Planck, they say there's no problem. There's DNA in this mud everywhere, and these are the mud fossils. So they know it now. Not a question about it, but they can't live with the fact that they're giants. So what are we looking at with clay? Clay is the soft flesh and skin and the muscle, and when it waterlogs, it preserves very well, because the water was in the 7.3 range, somewhere around there apparently, which is like ocean water, and that is what these tissues live in. They don't have an issue with that. They turn into the mud fossils, and literally turn into pieces of meat and so forth in some cases. It depends on how the conditions and how they ended up. Let's just put it that way. I can explain every bit of it, and there's a lot to explain. There's a lot of conditions, there's a lot of different chemistry, there's a lot of different geothermal activities, there's different solvomorphism and electrical potentials and blood and the transitions metals. It goes on and on and on. But let's stick with the real basics today. Just the basics, very simple. What turns to what? Clay is your flesh and your skin and the muscles, and it waterlogs and it turns into red clay, and sometimes it's white skin and so forth. Okay, now, and that's your kaolin clays and your red clays and all that business. Now, what's next? Your limestone. Well, that's CaCO3, calcium carbonates. And what does that mean? They're literally forever. Those things just don't go bad. They are they don't rot, and they don't go bad in the salt water, just like the fleshy stuff. And when the salt water dried out, they turn into those basalt columns and so forth, like a giant's causeway, which is literally a giant. Now, they have mineral incursions, and they have kaolin clay, or those little red slippery kaolin clays and yellow clays around the outside. And you say, well, what's that from? That didn't come up from any volcano. No, obviously it didn't. It was the synovial sheath, which is a slippery, gooey, clay, slimy sheath that surrounds every single fiber in your body so that you can move and flex. Because in your body, they are limestone. The exact same thing in your body. The calcium, CaCO3 in your body, if you look it up and see what it's made out of, that's what your tendons are made out of, your connective tissues. And they don't go bad. Now, what happens with the bones? It disintegrates, it absolutely disintegrates. And why does it disintegrate? Why doesn't it disintegrate in your body if your body is 7.3 pH? Because your bones are in their own little sacs. I'm telling you that. You look it up. Your bones are protected away from that salinity in your own body. Once you die in a flood situation and you're stuck in the mud and buoyant and floating, and your body is invaded by salt water, the normal tissue says, I'm all right with that. I can live with that. You know, that's what I was living in. I don't know, the blood's not moving anymore, but I'm okay. And the gaseous things, the volatile organic compounds, which are the gases and things that would normally explode in the outer, you know, if it was dry and it was heat and so forth, they bloat up and explode. But in the water, they go into solution. You still get waterlogged and bloated, but it's not the same as the process that happens on the water, which ends up with bones because everything else gets eaten and you get the scraps left over. Exactly opposite. This, you get the perfect things, and the scraps are, there is no scraps. No, they're what they are. They're the exact same. You know, every one of these down here was a body part, and there's some down here that are, that's a foot. That is what we call a no-toe. That is a foot, and I have many, 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 many of these, and in every different state of decomposition. And Tish Egerton has an absolute fabulous collection of them, totally unexamined. You know, we've asked for people to look at, but they're not interested. This is a very hard pill to swallow, and that's why I'm going public with this, that I have to have somebody take a look at this. It's DNA tested. This was DNA certified as human, DNA certified as human, which is a lung, the same size as us. This is a fingertip, and I will show that in better detail in a moment. It's always got the vein and arteries in it and everything. And that was CAT scanned, CAT scanned, CAT scanned. All this stuff pretty much, well, not all of it. There was like 7 CAT scans. Now, and I will show you a little bit of that in a minute. All I can say is these are the things that your body turns into. So clay is the soft tissues. Limestone is the tendinous connective tissues. Bone disintegrates, it's gone. Bodily fluids and vugs, the holes in like lungs and so forth, they fill up with crystals, silicates, and they are the gems and the jewels and the crystals. That's where crystals form. Like this here is a fingertip. Let me see if I can get a camera, a little light on this. You see that right there? That's a fingertip. You see at the very end, if you can see that little crystal sticking out there, these are garnets. That's where the blood shoots out at the very end. And doctors understand that. If you look on the right, there's a little white dot, and on the left there's a little brown dimple. That's the vein and artery. Vein is on the left, the brown dimple, which has that is actually the vein clamp. And on the right, they blow out. You see the little white spot. Now, and that's a fingertip. And that is the blood that leaked out on the bottom. And it's garniferous. You see the garnets on the end? That's what crystals form from. And you see the crystals form from all the blood and the bodily fluids and so forth. That's just what happens. Now, and I'll go into all this. And then the bones, here's what happens to the bones. I said the bones transition. Here's what happens. There they are. That's a bone head. Now, you see in that little hole there? You see all those little tiny holes? Those are the little ligament attachments. Those are, I show these little tiny balls all over the place. But in nature, you see them out in nature, absolutely enormous, because the creatures were enormous. You see down here? I don't know if you'll be able to see that at all. I'm trying to find it myself. Oh, there it is, right at the top. That is the absolute final remnant of the bone. You see how it's black in there? That's what happens to bones. They turn into hydrocarbons. That's what makes methane gases and all that. You see this still has the cartilage up at the top. This wrapping here, and you see that little triangular looking thing somewhere around here. Yeah, you see that triangular looking thing right there? That's how they wrap right around the bones, and they seal on those seams. They call that they call that tunica. It's amazing, isn't it? That's a bone. Now, and of course that was the lung. You know, lungs are like this, and sometimes they go like this. This was in, like, I think acid or something. It was in a condition where it took care of all of the organics in there and left the scaffolding. The other ones, there's lungs and giant fingertips, and this is what happens with blood. Here's how this happens. You see, in your body, you have red blood, and then it ends up turning into blue blood, which is the deoxygenated. Now, what you're looking at here is skin. You see all those little black dots? Little dots. That's the silicon that's in your skin. And all this little mineralization, these little white spots, that's minerals that they make your skin tough. Now, inside is this. We break it open and you look. Way over here is where the arterial blood came down. And it's rich with oxygen there. And as it goes through these little tiny blood vessels, if you can see all the little bitty holes, it works its way over to the other side where it becomes, you know, it's yellow, and then it comes browner, and then black, and then right over here, black as ace of spades. And that is where it gets sucked right back up into the heart and lungs to get reoxygenated. So that's the process of movement of blood in the rocks, in the tissues that were alive at one time. These things were living and they died. Now this was CAT scan and DNA tested, and that's the phalanges carbon silhouette. Let's see if I can get it light on it. You see that black looking thing? That's a carbon silhouette of a distal phalanges, which means that's the tip of your finger. Here you have the vein on the right and the artery on the left. The arteries blow out. The veins clamp off. So this right there, there's where the vein should have been. And that's where the other side of the vein is, right up there. And that little triangle is where the tendons stick in. Now at the very end, you see you have a vein to the right which doesn't blow out, and you have the artery here which always blows out, or pretty much always does. And that's the artery there on the sides. There's two artery holes there. That's where that blows out from this artery side. All right? So that's a fingertip. And this one over here is another fingertip. I'm not going to hold that up in the air forever. No. That one there, I have CAT scans of it, and I'll show you that. And we broke off the edge to see inside, what's inside there. But what you're going to see here is the chemistry of how tendons hook in and so forth. You see that orange-looking stuff right there? That's not just rust or something that happened accidentally. That is the chemistry of how these tendons hook in. Now, I don't have that actual molecular breakdown, but that is where they attach. You see, this is the black and the so forth. That's where the blood is. This is the vein side. The other side is the artery side. And that's how veins, fingers and toes get their blood. One side has the vein side and one side has the artery side. All right, the artery side is over here. It's reddish looking stuff. And these triangles, once again, you see those triangles? Those are, and you can see that orange looking stuff inside here and there. Those are where the tendons hook into the sides of your body, of your fingertip. And that's the fingertip. And this one here, this is what they call an apical tuft. So you get some, I probably couldn't see that fingertip. I had it too tight. But I can't start over again, sorry. And there's a lung. That lung was DNA certified. This one here bled all over the place. So, and that's a giant fingertip there. And that's an apical tuft, which is the very, very tip of a giant fingertip. And that's where all these little balls are, where these tendon balls stick in and hold. So, this is the real basics of mud fossils. And, I mean, I'm serious. I have every single stage of decomposition and every different, I mean, I filled a 200-foot drainage ditch with the remnants of what was tested here, and kept a lot, thousands of pieces that are very, very indicative of the way this process works, and they are already tested. They're CAT scanned. Anatomist checked them and says, yep, you're right, this is exactly what you would expect. And that's what they are, and the chemistry's been done. I actually recreated mud fossils in my little shop here, and they came out as a very solid, but not completely stone product, just like this. And this is what we find in antiquity. They used those to mold, and then as they dried out, which mine dried out, and now it is literally like stone. But originally, after the original starting to dry out, it was hard, but not hard enough, not like stone. But now I can see that it is converting itself into stone as it continues to take on more and more oxygen and dry out. So that is the process of mud fossils. Now, you're going to have to come up and look up on my YouTube channel and stay around there for quite a while if you want to learn how this stuff works. But I'm going to show you a couple last things, and then we'll go on from there. Because, you know, the new website is going up, and, you know, we're going to probably get a little bit away from YouTube and so forth and all these different things, and sort of concentrate up on that one particular platform, because you know, things are, you know, I'm afraid to post anymore. I got to be honest with you. I get shut down every time I post almost. You know, I got shut down for something today. I don't know. I had a wrong word in there or something. Nothing nasty. Just asking the questions. Why don't somebody look into this? And it's apparently you can complain to, and then they just shut you down. Because I don't think I'm doing anything wrong. I'm just asking, why is this not accepted? This is stuff, it's DNA tested. You would go to a court of law, they'd accept that. The CAT scans, I have the specimens. I'm just making claims that are, you know, somebody should do a peer review. And I'll show you what happened right over here now. If you look back here, it says published 2015. December 2015, huge giants, CAT scan, and what did I say here? Discovered in 2012, completely validated now by independent testing. Requests have been made for examination by leading universities, but no takers so far. That's like 3 years ago. And there's still no takers. There's not one single response in that time. And I send this out daily to these people that are making all these claims about, oh, Crowley Lake is some kind of animal burrows. There, it's hair. Another one is, well, they won't look at the dragon in Morocco, or the fish over there, or Atlantis. All of that stuff I've been posting about for years. They won't look at my giants. It's CAT scan. It's DNA tested. Well, this one isn't DNA tested. That one's CAT scan. But here it is right here. And it was anatomist certified. This is not just, I'm not guessing, this is it right here. And that's where I tell you where the tendon hooks in on the side. They hook in just like this, so you move your hand around. And this is the, you see, this is where tendons hook in. They have different chemistry. There's things going on they just don't understand, and they haven't been paying attention to. And they, see, it's right here. You see, that's how the tendons, see that color? That color's not there for nothing. That color is what they call, it's a transition metal is in there somewhere. And that's how your tendons work. Now, if you don't have that, I think you're going to have trouble with the tendons. And I think I found a lot of things in this particular study that I've been doing that indicates health and non-health. And I'll show you an opalized heart in a minute. But let's just look at this real quick, because everybody asked me about the CAT scans, and here's what happened. I had a Windows-based machine. Jesse Garant did these CAT scans for us, did 7 CAT scans, fabulously done, magnificent work. And he did them in the interest of science, and I praise him, and everyone should salute him for this. Jesse Garant was the only one that would speak with us about this, and he was the only one that would do this. He did it for nothing because he understands. And I also had trouble finding somebody to do a DNA test when I told them that they were ancient coming out of rocks. And then when I told them they were giant human beings, they went crazy and would not do it. And I could really find only one guy that was willing to do it. Helix Paleo Labs. And he's willing to test whatever somebody puts to him and go into the national databases, extant and existing, you know, the dead and the currently types of DNA that was ever in the history. And he You got this one. It's Homo sapien mitochondrial DNA, and there's two regions they look for in these very specific tests, which are ancient protocol DNA tests. So it's not something that was just, send off a little swab of this. Not only that, I know where the blood is in these. I know where the arteries are. I know where the veins are. I took it directly from the arterial blood supply. And it was dense in 2 of the 3 cases. One was not as dense, this very eroded fingertip that had the distal phalanges looking silhouette on there, because that had just been, but it was still there. It was still there. It wasn't as dense. The other ones were absolutely dense, just like you could do a transfusion. Now, anyway, and I can show you one that Gary Evans found over in England, a mudfly. You could just about transplant the lung. I will show you that. But here's what's inside of these. That was that apical tuft area. And here's more of the CAT scan. And this is the side where, and you could see the everything. I had it all done. I mean, it's not something that I'm making up here. And this is where the pads at the bottom of the fingertip are. But what happened, and he goes up to, you can go up and down in all the different ways and see all the different blood vessels and so forth. And this was the whole hand. This is the palm of the hand. Of course, I didn't have that CAT scan. But I got most of the, no, not most, but I got several fingers, a knuckle, all kinds of stuff in there. So, that was 3 years ago. Nobody will look at it. They say, well, where have you had this published? I said, nobody will publish it. Well, we're peer reviewed. Nobody will peer review it. Professor Derek Briggs down at Yale refuses to look at it. Absolutely refuses. I've been years trying, and then they say, well, where'd you take it? We'll take it to Yale. You're right down the street. I say, you won't look at it, and then they laugh at me. So I'm just showing what it is. So at some point, this should be taken serious, and I think the people that are taking money for telling people what to think should do a little more thinking. See that? That is a rock. It's just exactly like a piece of meat. Here it is now. I mean, it might be a little more brown now because that's exactly the way I had it. Hold it right there. You see that? No. And I mean, it's a piece of meat, no question whatsoever. Even in here, you can see the elastins. There's a black wavy elastins. You got to get with a microscope. I got a couple of microscopes, and you can see it very, very simple. So, and I had a butcher even look at it. I mean, it's what it is what it is. It's not hard. It cannot be denied. And it is being denied to look at. Just refuse to look. If we don't look, it doesn't matter. If we don't look, it doesn't matter. Of course it matters. It's time to look. All right, the illustrations I'm using here are not mine. They come from independent research. And this talks about limestone, which I have talked about, and all the way back to the mud. So you got your clay all the way up to your calcium CaCO3, and all the way in between is the different accumulations within the body. Once again, I did not create this. This is sandstone, mudstone, limestone. These are the different frequencies that indicate what the different minerals are that are in there. And you got silicon, calcium, magnesium, iron, aluminum, and these are the different colors and the quantities that exist in these different types of minerals. And the mudstone is literally the body part, and it has the different minerals in there that you suspect. And the sandstone is eroded skin and so forth from the outside, and it doesn't have the same minerals that the inside has, the calcium and so forth. It doesn't contain that. Anyway, you have to understand, you have to do a lot of research on this to see what is in each one of these things. And I could see how the body literally is structured. It's much better anatomical models than exists in medical. I tell you, Gary Evans found this over in a mud flat over in England. This is the actual blood vessel looking things that are inside your lungs, the entryways to passageways to go down. These are almost inert in your body. There's nothing that invades them, attacks them, or bothers them. They're just funnels. They're just to send things in different directions. The same with your blood vessels. This is the return blood. It's going to get reoxygenated. That is the oxygenated blood. It's the red blood. You can see it's quite obvious what's going on there. It's extremely old lung. And that's the lung as it started to dry out, and then it just dried out into nothing very, very soon. I think Gary told me it was a couple of weeks it ends up like this. And that's literally powdery. In the ground, if that became wet again, it would just deteriorate into nothing. The whole key with the mud fossils is in the 7.3 range pH, and then either once they come out of that, they dry out fairly quickly as waterlogged body parts, because they break up into fascia planes. Everything is coated with fascia. That lung was coated with fascia around the whole thing. Your fingers, your toes, everything has fascia around your tendons and all that stuff. So they break up in your lungs and all that. The things I'm showing you, they're body parts. They're chunks of your body, and they break along these fascia planes. And once they dry out, they're done. Just like they look in all the dry places for fossils, and they're finding nothing but scraps, because they have to stay wet. If they stay wet in these salty conditions, they last literally almost forever. And I'm going to show you what happens to them in a blood conditions. All right, that's a human heart, and this is the, of course, aorta and so forth up here. These are the chambers, the ventricles of the heart, and the walls, and these little fibers are, I believe they call those heartstrings. And I'm going to show you what will happen to one if it petrifies in blood. You're going to say, "Oh, Roger, that can't be a heart. Can't be a heart." It is a heart. That's the blood in the heart. These are the walls of the chambers of the heart. And these colors are the transition metals that are in your blood, and they have to be in your blood for you to be healthy. And because they are the transition metals that they work with what's called carboxylation, and they are sought out by certain other molecules. All right, so these metals want to attach to only certain molecules. And why would they only want that? Well, this wall here has to do a certain job, and it has to interact with a certain electrical impulse, let's say, and it needs a certain chemistry, like magnesium. I think they're talking about magnesium extremely important now. I don't know if that's true or not, but let's say it is. Let's say that's the color of magnesium, and you got a yellow color in you instead of a blue. You're going to be sick. That's what I've been talking about, these transition metals, and people don't pay any attention to this. Doctors don't seem to understand them. These are the things that, see this here? All these different colors? Every one of those little particles is a transition metal complex. And it's a tiny, tiny, tiny little molecule that carries another little molecule around, dealing with pH. A higher pH goes down to a lower pH, or vice versa, whatever. Because one picks up and one delivers. They bring down the oxygen, they pick up the carbon dioxide. And then your lungs blow out the carbon dioxide through a process called carboxylation. And they also use transition metals. And I'm going to show you that inside a little tiny lung right here. Let me grab one. Hold on. All right. This is a very small lung, but you see it cut apart here, and you see all these little spacey looking places in there. That's blood. Let me just bring it over here so you can see it better. All right, I hope that's all right. Those little cracks in there and all those little spaces in there, that's where the blood runs. See all that red stuff down in there? These are all the crystals. Well, you say, well, how come they're all different colors? And they are. This is not spectacular. Some of them are colored just like the lung like that. I mean, like the heart like that. Because they are made of the same sort of things. They're made of the same transition metals. Now, my feeling is that, you see see the little cracks all over the place? That's where the blood runs. That is running through these crystals. You see that crystal? That crystal is going to do something to that particular blood as it runs by, and then it's going to blow it out through your lungs. It's called carboxylation, and they come out as carbonic acids. I think it's a similar process to like a catalytic converter in a car. Look at all the different colors and all the different they call these, the geologists would call this shock quartz. It's not shock quartz, it's a lung. And they do this. That's all I can say, they do this. And I have many and many, many of them, you see, and this is, that's what they look like on the exterior surface. When this probably was in a very light, bloody solution when it petrified. You know, some of them are like this one here, I didn't cut apart, but that's the same, basic same deal. There's different colors in there, different crystals all over. It's a little tiny lung, I don't know, chipmunk or something, I don't know. I have no clue what it's from, but they all have, you know, that's where it enters. See all that down there? You see all those different colors? Hold on. You got to get these things with a tiny little bit of moisture to see them best. The moisture brings it out, what you know, what you're looking at. Like this one here. That might be a little better. When you rehydrate something, color jumps right back into it. See how quick that thing brought back the red? Anyway. Alright, so come up to Mudfossil University, come up here, 45,999 subscribers. You could be 46,000, you probably win some big prize, maybe a car or something, who knows. Anyway, come up to Mudfossil University, understand the reality, because there's much more to this than just giants and rocks and so forth. Having this community of engaged people, it's opened up a whole new world of research that has been denied and is being resisted. So you have to come up here if you want to learn reality. I'm serious. If you want to learn reality, this is the only place you're going to learn it. It's my claim. That's my statement. You go to the other places, they refuse to examine reality. So what are you going to get? You're going to get their opinion, and that's my opinion. And I have my opinion, and that is my opinion. So, come up here, Citadel of Truth, an oasis of intelligence in the desert of delusion, and we'll be glad to have you. There won't be any charges that we can levy against you. So, I hope you have taken away something from this, and I hope we can go forward and understand the true meaning of this, because it's a lot more than just a giant here and a big old guy there and rocks are like blood and things. Wow, it's cool. Wow, it is cool. But if you continue and follow the clues and do a little more investigation, it's a lot more than cool. A lot more than cool. So you do what you think is right, but I think you should do a little investigation of what we're doing here. Now, I have the new channel is going up here. And I got here, this is the, well, Mudfossil University is right now being set up by my good friends, Azar. I have a hard time pronouncing that, Zarar. You're doing a fabulous job, my friend, and my other good friend, Jody. And they are going to be setting up a book for me, I hope. I'm going to do the research, and they're going to set things up and take care of the website and do all that stuff, because I am terrible at all of that. And up here is the DNA tests, and Zarar is he does publishing, and I think you should look into anybody needs something done. He's very he does a good job, let me put it that way. You'd have to talk with him. I don't have much to do with his business, but he's doing this for me gratis. And so is Jody. I don't want any money, and I'm not going to take any money, and it makes it a little hard. You know, I always said it was hard to get good help when you don't pay them. But you know, we're getting good help, and I can't pay anybody because I don't have any money to pay them, and I'm not going to ask for any money because it's not what it's about. Anyway, bacterial DNA extracted from each of the 3 submitted mud fossils in a gene clean ancient DNA extraction kits, and according to manufacturer's instruction, 50 microlayers proteinase K solution added each sample, incubation 56 centigrade incubation carried out. I mean, it goes on and on and on. And I mean, this was a long time. It took like 3 months to do these. This is not a 15-minute job. And it ended up coming up with all these different, whatever they are. And I don't know what this stuff is. Read the report. It says positive, positive, positive. Negative controls negative. That's what you want. And these are the two that were very dense, and there was one that wasn't as dense, but it still had the enough DNA there to say that that's absolutely what it was these here, Homo sapien mitochondrial cytochrome B gene and Homo sapien mitochondrial D loop region. And then it goes down into all of the actual, molecules and how they're attached in those DNA strands, and that determines what kind of a creature it is. So it's not like something they guessed at. And it's a certified test. It's a certified lab. These guys know what they're doing. There's 2 labs that did it. So that's what it is. All right, so Mudfossil University learned the truth about what you are standing on right now.